Hey, Duke Dogs. We are having to put on our investigator cap again because if you saw the Peep and Chirp video, the question for today is, where did the water go? The mystery of the missing water. Last time for science, our burning question was, where does water come from for rain and snow that goes into rivers and lakes and puddles in the ocean? But today's burning question is, where did the water go? Because Peep never figured out where his water went. Duke Dogs, it is raining right now today. I can see that the cement is wet, the bricks are wet, there are raindrops on the driveway. But I also know that if the sun came out and it stopped raining, what would happen? Would I still see the raindrops? Would the cement still be wet? No, because of the amazing process of evaporation. Let me hear you say that. Evaporation. Evaporation. Duke Dogs, we are learning about part of the water cycle. The water cycle. That is called evaporation. Now, to know about what a cycle is, we have to stand up and we have to use our arm. We're going to make a cycle. We're going to make a cycle going this way. A cycle goes around and around and around. Or it could go this way. Around and around and around. We could do two cycles at the same time. Around and around and around. But the important thing is that a cycle keeps going. We are going to learn about the whole water cycle, but today the part we're going to talk about is just evaporation. Evaporation is what happens when water turns into water vapor. Oh, did you notice the same letters? Vapor is part of evaporation. In evaporation, water turns into water vapor and rises up to the sky. It's part of the water cycle. It's part of how things dry up. Have you ever put a wet towel outside on a hot day and it got dry? Where did the water go? It evaporated. It turned into water vapor and rose up into the sky. We also need to remember about how temperature affects the activity of molecules. Remember that very hot molecules, they're very fast. Can you show me some very hot molecules? They're just going around everywhere. They're doing this. Warm molecules, they might be doing this. Cool molecules might be doing this. Cold molecules might be doing this. And frozen molecules do this. Remember? Can you see evaporation? We can't usually see the water turning into water vapor except for when water is boiling. Now, I put this water on to boil and I see the bubbles. I can see the water moving around in there. Do you see the steam coming off of it? That is evaporation from rapidly moving water molecules. We can see the evaporation. Only near the pan though. If we go up here, it disappears into the air. But down here we can see it. I'm also going to put some hot water into this cup. And we're going to see if we can see some more evidence of evaporation. I'm going to take a plate and sit it over there for just a second. What do you think we're going to find on the bottom of the plate? If it's evaporating and it's very warm water, I can even see some clouds up here. If the water's evaporating, we'll see moisture on the bottom. I see some water droplets on the bottom of the plate. Duke Dogs, here's another way you can experience evaporation. If we know that the warmer the water molecules are, the faster they're going to evaporate, let's do an investigation. I filled these cups up about level, and I made a red line on each of them. I'm going to set one cup under a bed where it's going to stay cool and dark, and I'm going to leave the other cup in the kitchen here where it's usually warm and brighter. What do you think we're going to see when we look at them tomorrow? Which one will evaporate more quickly, the one in the kitchen or the one under the bed? Let's find out tomorrow.